Projectile projected from the ground. We have x and y axis. A projectile is projected at an angle theta with the horizontal. This velocity u has two components, u cos theta along x-axis, which is responsible for horizontal motion, and u sin theta along y-axis, which is responsible for vertical motion. This is the maximum height attained by the projectile, and this r is the horizontal range. This projectile motion is a combination of two motions, one horizontal motion where the velocity is u cos theta and the acceleration is 0, and next vertical motion where the velocity is u sin theta and the acceleration is minus g. Okay, acceleration due to gravity is constant, air resistance is negligible. Two-dimensional motion is a superposition of u cos theta where acceleration is 0 and u sin theta where acceleration is minus g. Projectile at an angle theta, let us consider any point here where the horizontal velocity is u cos theta, this is constant, and this is vertical velocity, Vy equals to minus u sin theta. We take Cartesian system. In Cartesian system, this is x, this is y dash, and the quantities here we take plus, and quantities here we take minus. And this we treat as origin, and since the vertical velocity is below origin, we take minus sign according to Cartesian system. Okay, this is horizontal distance x travel. This is vertical distance y travel. And this as the displacement from origin. X equals to ut plus half at square. The horizontal velocity is u cos theta and the horizontal acceleration is 0. That's why this becomes x equals to u cos theta t. And for vertical motion, y equals to ut plus half at square. Y equals to initial vertical velocity is u sin theta and the acceleration is always minus g. Ay equals to minus g. V equals to u plus at. Okay, the initial vertical velocity is u sin theta minus gt. With the help of this Vy, we can find vertical velocity at any instant of time t. Vertical component of velocity is 0 at highest point when the projectile is at its highest point. Vertical velocity is 0 and the projectile motion is driven only by horizontal motion at highest point. Okay, the resultant velocity is Vx square plus Vy square plus 2Vx Vy cos 90 degree. The angle between Vx and Vy is 90 degree and this becomes V square x plus V square y. Direction is Vy by Vx. The displacement from origin is clearly x square plus y square. Trajectory. A curve joining positions of the same particle in motion at different instant of time is called trajectory. Y equals to u sin theta minus half gt square. Let's substitute the value of t. T equals to x by u cos theta minus x square by u square cos square theta. Y equals to x tan theta minus g by 2 u square cos square theta x square. And this equation is in the form of y equals to ax minus bx square, which is an equation of parabola. That's why the projectile follows parabolic path. Time of flight. The total time for which the projectile remains in the air is called time of flight. Okay, let's take vertical velocity. At highest point, we can apply equation of motion everywhere because the acceleration is constant. At highest point, the vertical velocity is 0. 0 equals to u sin theta plus ay equals to minus g. That's why t equals to u sin theta by g. This is the time taken by the projectile to reach at the highest point. This is the time taken by the projectile to reach at highest point, and this projectile is symmetric. T, that's why the total time for which the projectile remains in the air is 2t. This is time of flight. Horizontal range. Horizontal range means the horizontal distance traveled by the projectile is called horizontal range. This is horizontal range r. This horizontal range is horizontal velocity into horizontal time. Horizontal velocity into horizontal time. Okay, s equals to ut plus half at square. This t the time of flight, and this s is equal to r now. Initial horizontal velocity is u cos theta, and time of flight is 2u sin theta by g, and the horizontal acceleration, since the velocity is constant in horizontal direction, the acceleration is 0. Okay, if the angle of projection is 90 degree minus theta, in such situation r dash equals to this much, which is equal to r. That's why there are two angle of projections for same horizontal range. If one is theta, another is 90 minus theta. For horizontal range to be maximum, dr by d theta equals to 0. First derivative should be equal. Let's solve it. We find theta equals to 45 degree. When the projectile is projected at an angle of 45 degree, the horizontal range becomes maximum. R max equals to u square by g. Maximum height. Okay. The maximum height attained by the projectile during its flight is called maximum height. Okay, let's apply equation of motion. Okay, at maximum height, the vertical velocity is 0. Initial vertical velocity is u sin theta. A equals to minus g. Acceleration due to gravity is always minus g. That's why maximum height attained is this much. H max, this height will be maximum if sine square theta is equal to 1. That's why H max equals to u square by 2g. Okay, when h equals to h max, theta equals to 90 degree, that's why horizontal range becomes 0. H max equals to r max by 2. When horizontal range is maximum, theta equals to 45 degree. This becomes u square by 4g, which is equal to r max by 4. Conservation of mechanical energy. In the projectile motion, the mechanical energy is conserved. Okay, mechanical energy at the time of projection is half mu square. At highest point when the projectile is at highest point, here this is the highest point h, potential energy equals to mgh. Let's substitute the value of h. This is this much, u square sin square theta by 2g. This becomes this much. Kinetic energy equals to half mv square. Half mv square equals to u square cos square theta. There is horizontal velocity only. Total energy equals to sum of kinetic energy plus potential energy. Okay, answer this half mu square comes common, and sin square theta plus cos square theta is equal to 1. That's why the expression equals to half mu square. At the time of hitting the ground, okay, energy equals to half mv square r. Let's substitute the value of resultant velocity. We get half mu square. We see at each point, at the time of projection, at highest point, at the time when the projectile hits the ground, at all the time the mechanical energy is same. This proves the conservation of mechanical energy during projectile motion. Projection from a height. Okay, a projectile is projected from height h horizontally with velocity u. The projectile is projected horizontally. This is the horizontal range. Okay, this is Cartesian system. Okay, this is positive. Horizontal velocity is u. Since the projectile is projected horizontally, the vertical velocity is 0. The acceleration due to gravity is always equals to minus g. X equals to ut. X equals to ut plus half at square. This is horizontal. Okay, x equals to horizontal velocity is u plus the horizontal acceleration. Since the velocity remains constant, the acceleration is 0, and simply x equals to ut. That's why t equals to x by u. For vertical motion, okay, this is origin, and this displacement here, this height s lies below the origin. That's why we take s negative. Okay, t equals to 2s by g. This is time of flight. And r equals to this r. This is horizontal distance. That's why this is horizontal velocity into time of flight 2h by g. Projection from a height at certain angle above horizontal. Okay, this is height h, and the projectile is projected making certain angle with the horizontal from height. Now, this velocity u has two components, u cos theta and u sin theta. Okay, this is horizontal velocity. This is along this direction, x direction, plus x direction, we take plus. This is along plus y direction, we take initial vertical velocity also plus. We take this height h is below origin, that's why we take this height h as minus h. Okay, ux equals to u cos theta, uy equals to u sin theta, and ay equals to minus g. For horizontal motion, x equals to u cos theta into t. That's why t equals to x by u cos theta. This value we use later. For vertical motion, minus h equals to this much, or gt square equals to this much. Let's substitute the value of, let's solve for t. T equals to this much. Projection from a height at an angle below horizontal. Okay, the projectile is projected from height h in this way, making angle u. Now this u has two components, u cos theta and u sin theta. Since this u sin theta is below origin, we take this u sin theta initial vertical velocity as minus. U cos theta equals to ux equals to u cos theta, uy equals to minus u sin theta, ay equals to minus g. This is horizontal motion. For vertical motion, this much. Okay, gt square equals to this. Let's solve it. T equals to this much. Projection from a moving body. Okay, a person is there in a moving trolley whose velocity is u. This project, E or C, projects a projectile at an angle theta as shown in the figure. Okay, along horizontal direction, the component of u is u cos theta, and the trolley is also moving in the same direction. That's why the horizontal velocity becomes u cos theta plus p for the projectile, and the vertical velocity is u sin theta. We solve accordingly, applying equation of motion as we discussed previously. Another case in which the trolley is moving in opposite direction to that of throw. Okay, the throw and the trolley motion are in opposite direction. That's why the horizontal component is u cos theta, the u cos theta for u, and minus v for trolley. That's why the horizontal velocity for projectile becomes u cos theta minus v, and the vertical velocity is u sin theta. Okay, here we have upward moving platform. He or she throws projectile with velocity u. This is u cos theta, and this is also u cos theta. Okay, in vertical direction, the projection, the direction of u sin theta and v are same. That's why we take here plus. That's why the initial vertical velocity for projectile becomes u sin theta plus v. And in this case, where the platform is moving downward, the initial vertical velocity becomes u sin theta minus v. Okay, this is the summary of the cases. 1, 2, 3, 4. Projectile on an inclined plane. This is inclined plane, inclined at an angle beta with the horizontal, and the projectile is projected at an angle alpha, which lands at A. The angle of projection with inclination is alpha minus beta. Okay, this is the direction of G. We take this inclined plane as x-axis and we make a perpendicular axis like this, y, that this is positive, this is also positive. Okay, the component of this acceleration due to gravity is g cos beta and g sin beta. Okay, x and y axis, the projectile, the angle of projection is alpha minus beta with inclined plane. Okay, this is x component, and this u sine alpha minus beta is y component. ax equals to minus g sine beta, ay equals to minus g cos beta, and ux equals to u cos alpha minus beta. Uy equals to u sine alpha minus beta. When the projectile lands at A, y coordinate is 0. That's we solve it. We find t equals to this much and x equals to ut plus half at squared. We find r equals to this much. For such videos, please follow our Facebook page, Physics with Physics.